All right, so today we're really going to start jumping into the scientific method or scientific inquiry. And this is a process or procedure that has kind of some steps that help guide you in an organized way in completing research, testing, experiments in labs. This is very pertinent to us right now because we're living through COVID-19 right now. And scientists are using this scientific method or science inquiry to help hopefully figure out a vaccine for the virus. And I'll use that as an example because it's something that we all experienced or are experiencing right now. Okay, so if we look at the scientific method, the first part is the problem or the question. You then have to do some research, and then after your research, you formulate a hypothesis. You then write and conduct the experiment and trials, and from those experiments and trials, you collect and analyze data and make observations. There's that observation piece I told you would be going with scientific method. After you have all of this data and these observations, you're then going to draw conclusions. After you draw conclusions, you're going to communicate the results. So what I'd like for you to do right now is to pause the video and write these steps down in your scientific journal or your science notebook. Today is the next day. I don't want to assign a date so that anyone can use this at any time, but it's the second lesson or the third video that you're taking notes from. So pause the video right now and go ahead and write this down. Okay, so each part of this method or this inquiry is super important. You can't take one out and throw it out because then it ruins the whole sequence and it ruins the organization of your tests or of your research or your lab or experiment. So, it's obvious that the first you have to start with a problem or a question. If you don't have that, then you're not doing anything for any reason anyway. It's not like, oh, I think I'm going to invent something for no reason. There's generally something that piques your interest or necessity comes about. And in our situation, it's COVID. The problem is we got this virus. And what are we going to do about it? Well, we know we can't get rid of it because the viruses they even live in the earth. Sometimes they lie dormant for years and years and years. Sometimes they just keep cycling. So we can't get rid of it. So our new problem or our new question came up after we realized we couldn't get rid of it, and that is, how can we live with this? Or how can we get a vaccine? We need a vaccine and protect ourselves from this. So scientists did lots of research. You can bet that they researched COVID 1, 2, 3, 4, 5, 6, 7, 8, and on all the way up to 19 and other viruses that are similar. And so once they completed their research and they had some kind of a background information on what's worked with other viruses that are similar, they start formulating a hypothesis. They say, if I mix this, this, and this, then that will make someone resistant to getting the virus. And so they have these hypotheses of different mixtures for vaccines. So then they start the experiment, and the experiment is what we call human trials. Well, they do other trials first, but we're at the human trial stage. So they're giving people the vaccine and they're collecting data and they're making observations on these people who have the vaccine in them. And they're analyzing it. They're saying, okay, what's working? What's not? Are there any bad reactions? I mean, a bad reaction could be on a whole spectrum of things. It could be like, oh, I'm not feeling so good, I have a headache, to, I have explosive diarrhea, to a really bad reaction, I guess, would be death or seizures. So they're watching these humans that are in this trial phase, in this experiment phase, and making observations on how it's going. Now, I can tell you that there was at least one group that stopped and pulled back because they were seeing their test subjects have a bad reaction. So they said, oh, we got to go back to the drawing board. Let's formulate a new hypothesis if we need to. And then they start the experiments up again. That's where we are right now. Now you can see that there's two more sections of the scientific method or scientific inquiry for them to go through before we have that vaccine. And that is, once they've made all their observations and they found something that doesn't cause adverse reactions or bad reactions, then they're going to conclude, hey, this vaccine works. This mixture of this, this, and this is successful. Now, they can't stop there either, because if they figure it out and then they don't tell anybody about it, they know the answer and nobody gets a vaccine because nobody knows. So then they go and communicate to the community or to the scientific community and the different labs saying, hey, we found this. Let us show you our data. Let us give you our observations. I think we're ready to manufacture the vaccine. And once the powers that be agree and say, hey, this is safe, then they finish this and they are ready to mass produce that vaccine. So you can see how the scientific method is super important. Sometimes they'll stop and go back to a section and restart that, like if they have to go back and do a new hypothesis. But this sequence is really valuable and super important.